Hello, everyone, and welcome to another video with me. This video, I am planning to continue my homework help for section 6.3.1, the applications of the distribution of sample proportion. So we made some headway in the last video. I gave you the three underlying assumptions. We talked about drawing the graph, and we talked a little bit about finding probabilities. We're going to do some more of that with this second example. The thing that you'll notice about this homework that's different from the other homework assignments is that it's more homogeneous, meaning the problems are more similar. And that's by design. We realize that you don't have access to this in the textbook. And so we want you to practice specifically the skills that are in the homework. So pretty much you're going to see the same thing. You're going to see test the assumptions. You're going to see draw the distribution, describe it, the normal distribution with the mean and the standard error, the standard deviation of the sample proportion. And then you're going to see us saying, find the probabilities, sometimes testing more assumptions. Let's look at this time at problem number 2 on your homework and see if we can make some headway with that. So we did problem 1 in the previous video. So let me look at problem 2 here. Problem 2, here we are, says, the campaign manager for a political candidate claims that 55% of registered voters favor the candidate over her strongest opponent. So we have 55% favor the candidate, okay? A simple random sample, remember those are our keywords for our assumption. We have an assumption that rests on this here. A simple random sample of over 300 voters was selected to collect information on whether they favor the candidate over her strongest opponent. This is my sample size. Are the conditions necessary to apply the central limit theorem met? So let's see. Okay, so as you remember, we have 3 assumptions and we have to write them out. So we're going to get this. So we have number 1. The first assumption is that we have a simple random sample, and simple random sample is stated. So this assumption is satisfied. Sometimes you can just write simple random sample, yes. What you want to see is a yes for every assumption, but for the sake of explaining it, I'm going to write it this way. Simple random sample is stated, so this assumption is satisfied. Number 2, the second assumption is that our 10 times our sample size is larger than our population. In other words, the sample is less than 10% of the population. So let's take a look. Remember that our sample, let's go back and check this so you guys can see. Remember I said this depends on judgment many times, but I've never seen her violate this. This is how you would think about this. There's 300 voters in your sample. And that population represents all registered voters in this area, maybe in the US, we don't know, but it's all the registered voters. So you have 300 people in your sample. 300 times 10 is 3,000. So can we safely assume that there are more than 3,000 registered voters in this area? Yeah, we can assume that. This is probably the US, maybe it's California, but regardless, this is safe to assume that this sample size is adequate, that it's not too large. So here, we're going to say that the sample is less than 10% of the population because the population of registered voters is likely more than 10 times 300. Which is 3,000 people. Now, the third assumption is where you have to do some math, okay? You can't get around this, you have to do this math. So 3, your third assumption is that NP is greater than or equal to 10, and NQ is greater than or equal to 10, okay? Remember, we have to go back to our percentages in the problem. So here, and we have N is 300. Your percentage, your P is 55. That's the people who favor your candidate. The people who don't favor your candidate is the complement, 1 minus 55%. So we're going to do that right now. So we're going to have this. We're going to have we have 300 people times 0.55. And that's going to be your NP. And then we're going to have the complement. So let me put up the calculation here. We have 300 people. I'm going to move my, whoops, I'm going to move my caption over. Give me a minute here. Let me share the correct screen. So this is 300 people. 300 people times, whoops. 300 people times 0.55. This gives you 165 people. That is definitely more than 10. Now, the other group don't favor them. And remember, we either do or we don't in this case. That has to add up to 100% or 1. So 1 minus 0.55. This is the percentage of people who do not favor a candidate. So we have 0.45. So in this case, we get this came out to be 165 people, which is greater than or equal to 10. So that's yes. And then we have to check the other assumption, which is NQ, which is, so NQ, remember, was, this is NQ. is greater than or equal to 10. And remember that here, this is 300 times Q is 45, which is 1 minus, you can write it as this if you like. Oops. 1 minus that. And this is equal to let's go to the calculator here. So we have hold on. Point 45 times 300 people. 135 people. Okay. So now we know these are both. So we can apply the central limit theorem. We can apply and find any probability that we want to find. So that's part A of this question. Now part B of the question. So again, this would be yes. And so we say that yes, the CLT can be applied since all of the assumptions are satisfied. Okay, that's part A. So this is 2A here. Now, moving on, let me go back to the problem itself. Part B says describe and sketch the sampling distribution of the sample proportion. Again, in order to do that, we need the mean and the standard deviation to do so. So the mean here is going to be the population mean, which we know is 55%. Okay. If you recall from either your studies or the previous video, when you're describing the distribution, we need to draw, obviously. Draw distribution here. Do that. We make it look normal. Something like this. Our mean is in the middle, as always, right now with a normal distribution. Your percentage is 0.55. Okay. Now, we know this is normal. So if you saw the previous video with the notation, sometimes you'll see it written this way. You'll see, my apologies. You'll see normal with an N like this. Oops. Normal. And then you'll see the mean, which is 0.55. Now, we don't know what the standard error is. We haven't calculated it, but the formula for this is as follows. It says sigma of p hat, which is our this is equal to p q over n. So this is pq over n. So here we're going to put in our numbers and find our standard error or our standard deviation. So we get, this is p hat. This is going to be the square root of 0.55 times 0.45. And remember, our sample size was 300 people. So we're going to have that. Remember too, that when you're graphing, that this result should be rounded to 2 places for graphing purposes only. For calculation purposes, like we do later, take it to 4 or more places. Okay, so let's do this calculation. Let's see what we've got. So this is the following. We go second square root, we go parenthesis, then we say this is 0.55 times 0.45. You can use parenthesis rather than the star. I chose to use the star here. Divided by, remember, keep it all under the radical, 300. Okay, and that gives us 0.0287 if I round to 4 places, 0.0287. So I'm going to take that number and put it here. This is sigma of p hat and this is equal to 0.0287. If you're going to round this to 2 places for the sake of graphing, it's going to be 0.03 because there's an 8 behind the 2. So what I'm going to do now is do what I did before and always what I've done, do my standard deviations, do 3 of them, and count by whatever this amount is. So I do 3 of these like so here. So 55 plus 0.03, this is going to be 0.58. 55 plus 3 is 58. 58 plus 3 is 61. So this is 0.61. 0.61 plus 3 is 0.64. 55 minus 3 is 0.52. 52 minus 3 is 0.49. And 49 minus 3 is 0.46. Okay, so they go 300 for each one of these. That is your standard, your distribution. If you want to describe it, this is 0.55 comma 0.0287. That's my description of the distribution. So that is this is describe and sketch. This is what this is. Find both of these. And I can write up here that mu of p hat. Remember, this represents our middle number. That's equal to the population proportion p. So that's what we're doing here. Okay, this is 2b. So this represents 2b. Okay. Now, continuing our process, we're going to go on to 2c. to see what is the probability that in a simple random sample of 300 voters, less than 150 voters favor the candidate over her strongest opponent. So we're talking about our sample here. Notice they didn't give us a percentage, they gave us an X. So we have to turn this into a percent. Let's take a look at that. Part C, probability that in a simple random sample, less than 150 voters. So if we go to our whiteboard and we're looking at the probability of, here we're looking at X is 150 voters, okay? We have to, first of all, turn this into a percentage, okay? So then, if we do so, okay, if we do so, we have the following. We have P hat, which is our sample proportion, is equal to X over N, okay? Well, our X is given to us. So this is not so hard. This is 150 over 300. 300. And that becomes, you work this out, and we will, you're going to see that that is equal to this answer here, 0.500 or 50% as your percentage. You could make this a percent. It's not necessary here unless she asks you to. But let me show you that calculation. This is 150. My apologies. I switched my screen share. So here we have 150 over 300.5, right? So now it says that we want to find the probability that less than 150 voters favor the candidate. So if you recall, let me go back to here. I'm going to draw a modified version of our last distribution to kind of jog our memory a little bit. Here's our distribution. Our mean was 0.55. So we're going to put that here. 50% is going to be on the left. So 50% is going to be somewhere here. And we're looking for less than. So in this case, we want this part of our distribution, right? So then that essentially tells us this, that the probability of X less than 150 is going to equal the probability of P hat, because that 0.50 that you see, that's essentially our sample proportion now. So P hat less than 0.5. And we're going to put this in our calculator. Now remember, what are we using for our mean and our standard deviation? That's why she had you describe this. The mean is going to be 0.55. Your standard deviation is 0.0287. So when you do this, you write the following. You say that this is equal to normal CDF. I'm going to go here. This is going to be, I'll put it down here where there's more room. Normal CDF from, remember, we're starting from the left, negative infinity. I'm going to write it as negative E99 to 0.50. Mean is 0.55. And standard deviation is 0.0287. We're going to put that in our calculator and see what we end up with. So let's see. I'm going to share a different screen here. All right, so this is second distribution, normal CDF right here. Going from negative infinity, that's correct, but we're going to the upper score, which for us here is 0.50, with a mean this time of 0.55 and a standard deviation of 0.0287. Paste it in. We end up with 0.0407. 0407. So here we end up with, this is 0.0407. And remember, if you're turning this into a percent, you can multiply by 100, but she has moved the decimal point over 2 places to the right. You get 4.07% as your answer. That is part C of this question. This is part C. So now I'm going to say, we're going to go to part D in just a moment. This is number 2C. And that's how you would work it out. This is 0.0407. Okay. Now, going along here, we have a part D to this question. So let's look at it. Part D says, what is the probability that in a simple random sample of 300 voters, at least 60% would favor the candidate over his or her strongest opponent? So we have the percentage this time. We know what, so basically we just have to figure out which way we're going and we have to plug it in. So let's look at the diagram here. This is 0.55. 60% this time is going to be over here. So this is 0.60. At least 0.60 is going to be here. That's 60. So now you're going to shade this part. And we're going to look at this piece of the distribution. So we have this. You write probability of p hat. We don't have an x this time because they gave us probability directly. P hat greater than 0.60 is equal to, and we put in the same 4 parameters just from a different point of view. So it's a normal CDF. Our left this time is 0.60. Our right is going to be positive infinity, E99. Our mean is the middle, which is 0.55. And our standard deviation is 0.0287. We do that, and we get our answer. Let's go to the calculator and compute it. So here, second distribution, normal CDF. We have 0.60 because it's our left. Our left end. Our upper this time is E99. Remember to get our E. We don't want to use the letter E, not the green letter E, but we want to use the letter E that's on top of EE for enter exponent. And that is on top of the comma, okay? So we're going to go second comma, E99. Mean is 0.55. Sigma is 0.0287. Paste it. We get 0.040746. Okay, so it's very close to the same amount that we had last time. It's not exactly the same. You'll notice that in the next decimal place, it's different. This is 04074. This is 040740159. This answer has a different layout, but it produces the same result. So what I'm going to do now is I'm going to show you and remember, she does give you the answers down below. And I know we've had some issues with this in the past, but this is the same result to 4 places, and she is taking it to 4. So you do have your data right here. Okay, I hope that this helps you. I'm going to go back one more time to the whiteboard here. This is the same results, but with a different, it's the same result, but with a different set of numbers. 0. Is 0.04. 4.07, which is 4.7%. 4.07%. Whoops. And so I hope that this has helped you. I hope that maybe you learned something from this video, and I will see you again in my next one, folks. Hopefully, like I said, these videos are helping it to sink in for you. And if you have any suggestions or comments about videos that you'd like to see next, please be sure and let me know. Be safe, everyone. I'll see you in my next video. Thank you so much. Bye for now.